we talked about last time. And HTML is not a programming language. HTML is a markup language. It is used to describe how something should look, make the text bigger, or make the text blue or italic, which is fine, but yeah, that's how people make web pages, the simple web pages, although most websites now are very active and personalized and have a bunch of scripts behind the scenes that are written in real programming languages like Perl and PHP. But the web page itself is just a static text document with a bunch of formatting tags, and it starts with an HTML tag and ends with a /HTML tag. And you've got heading tags and paragraphs and breaks and bold and italic and stuff just to specify how things look. So this text that's got some tags like H2 and /H2 will be rendered by the browser by making some font big and some font small and such. So everybody loves HTML, I think. I loved it. It's the world's best box of crayons. Even somebody with no manual dexterity like me can make something look good with this. It's sort of like building things out of Lego. But it's not a programming language. You don't have variables that can have numbers. You can't loop or count through things. You just describe what it should look like. So you need programming languages behind it to do the logic for active web pages. Like you might have a search engine where you're going to search for something, and you can't do that in HTML. But HTML can call a routine in another language. And in fact, the HTML is very strange in that there are many languages like PHP intended to be included in the HTML file that look like comments to the HTML parser, but not to the PHP parser. So you have this horrible monstrosity where you have 2 or 3 languages all mixed together in the same file. And as you can imagine, that easily leads to confusion and security errors. But anyway, Perl is a language designed specifically for handling text. You input text that's structured and pick out the fields and such. So very well developed, this language, just for that purpose. It can run on any platform, and you can write attacks and scripts in Perl, although these days most hackers use Python, which is more popular, but you can write Perl. Perl is much easier. Remember how hard it was just to write hello world in C? You had to have an include and a main and a bunch of parentheses. In Perl, you just say print, quote whatever, and then put a semicolon at the end. It's very easy, almost as easy as BASIC. So Perl can be easy. Perl -H will give you help switches. People often run Perl interpreted. Remember when we wrote C, you had to compile it down to binary code and run the binary code. Perl, you can execute a command one by one, just like bash at the command line. You just type in commands. It interprets each command one at a time, which is much slower, but much easier for beginners to understand. So you've got format characters like string and character and unsigned integer and octal and all that jazz. Like C, functions have a sub in front of them. Variables all have $$ in front of them. You have an ampersand character when calling a function. So it looks really strange. Here's a subroutine called speak. Here is a word with a $sign to make a variable, and then you call speak with an ampersand. I don't know why he did it this way. These strange punctuation marks, not only are they confusing to read, the same punctuation marks are used for completely different purposes by other languages like C. The ampersand there means a pointer, a level of interaction. So this is why it's very easy to make ridiculous mistakes. If you use more than one language and you have to use an unfamiliar language, I know there's several mind-boggling things. I'm used to C, where white space doesn't matter. You can put in all the carriage terms you want, all the tabs, nobody cares. But in Python and Bash shell scripting, white space matters. And so I was befuddled why my programs kept crashing. Anyway, that's why most people learn 1 or 2 languages that they're really good at, and they try to avoid the others. And if you have to cover a lot of languages, what everybody really does is they just Google and they go to Stack Exchange, where they have good examples of everything, and you find somebody else's program that's close to what you want, and then you modify it a little, or you patch 2 of them together. That's typically how people write code. The internet is a fantastic resource. So here's what a for loop looks like in Perl. It's very much like a C for loop. No real difference, unfortunately, except for those $signs in front of the variable. Here's testing conditions. If IQ greater than 7, do this, else do that. That's, again, pretty much the way it would look in C, except dollars is the only exciting thing here. So there are a lot of other kinds of programming languages. So originally, there was spaghetti code, unstructured code where you would run code, and if you want to go somewhere, you'd go to, and then you'd go to somewhere else. And people discovered that anything bigger than a couple of pages long becomes unmanageable with that unstructured system, so they switched to structured languages that had subroutines. You could make a subroutine that opens a network socket and a subroutine that prints out a page, and then your main routine would just call this function and then that function. But then, in the modern world, you have another level of abstraction necessary. You might want to make a data object that includes data and methods. Like you're a company and you have a bunch of employees, but every employee has got not only a name and a social security number, they've got a position in the company. And there are things that will send an employee on leave for a week, a function that would do whatever it takes to put them on leave, or promote them to the next level or something. So each employee is a data object that has data called attributes and active code called methods attached to that employee, and they call that an object, and it's object-oriented code when you have these objects and you move them around. So that's what the modern languages are like: C++, C#, Java, Perl 6, Object, COBOL even, for God's sake. These are all object-oriented, so they have the next level of abstraction where you have these complex data structures. And of course, the next level beyond that, which is not in your book, is artificial intelligence, which is really coming into its age. It was just a stunt for most of my life, but in the last 5 years, the Stanford has a free AI course. You can take it online, and people have actually solved captchas with that and done other things. Now, smart machines are really coming, where they figure things out, they learn it on their own. Basically, they write their own code, figuring out how to do something, and you train them the way you would train a person. You put them in and they practice doing something, you tell them if they were right or wrong. You do that 50,000 times, and they write their own code as necessary to figure out how to accomplish the goal. So they're not as smart as people, but they're much smarter than just obeying instructions that a human put in code. They have some ability to learn, sort of up to the level of an insect. Insects can learn how to run a maze, and that's quite valuable. Anyway, so object-oriented programming, you have classes. These are these data structures that include data and functions, and you have a symbol like : in C++, which separates the name of a class from the member functions. Now you have employee : get employee will get the information about one employee or create a new one. There is a constructor that creates a new object. There's a destructor that destroys an object when you're not using it anymore. And these methods are all out there. So you'll have a class that has static data like name and place of birth, and then functions attached to it like get employee, promote employee, fire employee, pay employee, calculate taxes, and all these things that you might do with an employee. Ruby is what Metasploit is written in. Ruby was written by a Japanese programmer, and it is very beautiful and clean and logical. And some people really love this. People that used to like languages like C or something, they often switch to Ruby. Metasploit was written in something else, and they recently rewrote it in Ruby. It looks pretty nice. Here's the require lines that bring in libraries. Here's the class that defines the Metasploit class. Here's the : to specify the methods. And then you have a license, and here's the author and all this jazz. So this is what you have to use if you want to publish a new Metasploit module to let people do an attack. And if you look at Metasploit modules, they're very easy to read. It's working out very well for Metasploit, and there are Ruby fans just like there are people who love Ruby on Rails. And then there's other languages that are out there for jokes, like there's lol code, based on memes, where you start a routine with I has a var, I'm in your loop, up var, I'm out of your loop, everything ends with K thanks bye. That's written. So here's, you can even take a class online and learn how to lol code. You write programs in lol code, visible, kitten name goes here. That's how you print. And so and then that's one of the languages. And then there's brainfuck. Brainfuck is a category of esoteric programming languages. See, normal programming languages are intended to make it easy to program by making it more clear. But there are some people who said, how about we go the other way and make it as difficult as possible to program? So in brainfuck, there are 8 commands. Now, brainfuck actually implements the original computer. The original computer was never built. It was the Turing machine. Turing figured out the mathematical significance of computer programming with this machine he made up, where you have this long line of bits that are either 0 or 1, and you have this thing that sits on there like a stapler, and it can change the bit that's underneath it, and it can step to the left and right and change this bit. So it's very different than the kind of hardware we use, and that's what brainfuck implements. And it only uses 8 characters for the language. this increments, moves to the right, this moves to the left, this adds one to the bit you're sitting on, this subtracts one, is a byte you're sitting on. This outputs the byte, this takes a byte of input, this is part of an if, that's part of an if. So you can write programs, and here, for example, is hello world. The one we did in C, that will print hello world in brainfuck. It will take the original bytes that are 0 and increment them to turn them into the ASCII for hello world. So it increments this to be an H, it moves to the right, increments this, and the brackets make some kind of if statement. And if you learn how to read that, you've achieved a certain level of fantastic eliteness, sort of like someone who can solve the New York Times crossword puzzle. You've achieved a certain intellectual score, like being a chess champion or something. Anyway, those are the languages that are out there. And they show, people playing with the concept. Any language that has branching, looping, and testing can do anything. The only question is, does it make it easy or make it hard? And there's some people who go out of their way to make it hard just as a stunt. Anyway, so I got a few more eye clickers, and that's it for today. All right, so which of these is not a programming language? One of the CTFs had brainfuck code in it. It was convenient that I knew it. And then one of them had Haskell. I have no clue about Haskell. That's why I said we really need real coders in our coding club, our hacking club, because Haskell is pretty difficult to understand from the outside. Only real computer scientists know Haskell. Anyway. All right, so that's HTML. HTML does not have branching, looping, and testing. You cannot really do arbitrary things in it. You can only do the one thing it's designed for. All right, which is most commonly interpreted instead of compiled? I'll quit at 25. All right, and that's Perl. Perl is commonly interpreted. By the way, we should talk about Java, because Java is a special case. See, the reason you may have noticed, especially in some of the projects, and if you go into more advanced classes, you will suffer more and more getting Java to work. Java is very hard to use. It can't even write an installer that works. You install Java, and then it doesn't run. And this is like the result 90% of the time. I don't understand how they can get away with such crappy stuff. You have to go through, digging through blogs how to patch it. Anyway, people put up with all that because Java has one advantage. When you write Java and compile it, it does not compile to machine language. It compiles to bytecode, which runs in a Java virtual machine in any environment. So you can write something in Java and it will run on Android and iOS and Windows and everything, and you don't have to rewrite it. Otherwise, every company has to have a division writing Android apps and a separate division writing iOS apps with a different team of programmers writing a different language and a different team. That's why people put up with incredible problems with Java, because that saves you a ton of money. Interoperability. It also means that Java apps run slower and buggier, and it also means that the code you're distributing is very easy to read. It's much closer to source code than to machine code. But anyway, that's why Java is a special case here. Java compiling only goes halfway to machine code, not all the way. The other half is done by the Java virtual machine on each device. Anyway, that turned out to be very effective for certain applications, and a lot of people still use it, even though it has serious problems. So, which one of these puts a dollars in front of all the variables? All right, I'll quit at 25. And that's Perl. All right, good. All right, which one is object-oriented? All right, I'll quit at 25. All right, that's C++. C, by the way, The original C was extremely logical and beautiful, sort of like Ruby. You can tell a very clear mind made it. And C++ is just like a pile of garbage. When I was a kid, you didn't have money for anything. If you wanted anything, you had to go to the garbage pile and build it. There's just old boards and nails and broken pieces of tractors and stuff. And that's what C++ is like. There was like a popular page out there that claims that C++ was a joke, intended to show something no one would really use. But anyway, it's the way you really do things now. It's object-oriented. It has all the new features just sort of plastered on top in a chaotic mess, sort of like a Microsoft product. Microsoft products are actually like the Frankenstein monster. They buy companies and just patch in their stuff, and then they buy another company and patch in their stuff. So there's often inconsistency and illogical stuff, and there's always like 7 different ways to do the same thing. It's very strange. It's very non-mathematical, very business-oriented. It has stuff that a manager would want in a business, whether it really makes sense or not. Whereas C was designed by like mathematical, logical people. There is one instruction to move, and since you don't need a separate one to copy, there isn't, and so on it goes. Anyway, all right. And there's the last one. Which one of these is primarily for file input and output? I'll quit at 25. All right, that's Perl, practical extraction and reporting language. If you try to do file input in C or Fortran, it is very, very painful. It takes dozens of lines of code to read something and parse it into columns. You can do it in Perl in one line. That's what it's for. You can take a whole file, read it in, and parse it into columns all in one statement. Anyway, I'll see who won this. We turn off the recording, and then I'll clean up and go upstairs to the lab to help anybody that wants help up there. It's here. 123.